Hi. Before the break, we were looking at ways in which modern humans are similar to the primates that we're related to. In this segment, we're going to focus on how we're different. We saw in the picture earlier on that although we share about 1%, or we share 99% of our DNA with chimps, we only differ by about 1%, we are very, very different organisms. So let's focus on some of these differences now. How are humans different from other primates? Well, first of all, and I think very significantly, we are bipedal. This means humans walk upright on two legs, and of course this then frees the hands for other things. Now you may have seen chimps and gorillas and other primates walking on their hind legs, but that isn't true bipedalism. If you threaten those animals, or if those animals need to get around, get from one place to another place, locomote in a most rapid form of movement, they will drop to their all fours and work quadrupedally. They will walk on all fours because that's the way they can get around the most rapidly, and when they're threatened, that's what they need to do. However, humans are bipedal by choice. This is our best form of locomotion, our most rapid form of locomotion. So we are clearly bipedal organisms. And what does this allow us to do with our hands? Well, we can carry other items. When we're threatened, we can pick up a baby and run away with it. We're not struggling to hold the baby and then locomote on three legs, or throw a baby onto our backs like some baboons and monkeys and chimps might do. We are free to carry things and operate weapons and tools. So we can defend ourselves using our hands. We can make things using our hands. When you're bipedal, you locomote higher off the ground. You can therefore see further. Remember, we spoke about the fact that we have stereoscopic color vision, so we can see much further. That means we can see danger approaching. It gives us a survival advantage, and we can possibly see food from further away. It's also something very important in that bipedal locomotion facilitates face-to-face sex. Now you're probably sitting there giggling and thinking, how on earth can this be of importance? Face-to-face sex encourages a kind of bond, a love bond that will exist between the mating pair. And this is lying at the foundation of our culture, of our civilization, of the fact that we have a social interaction and we tend to pair bond for very long periods of time. We have a flatter face, okay? We don't have protruding jaws, and this facilitates our speech and our communication. We have much smaller canines than other primates, and this is an adaptation to an omnivorous diet, less reliance also on sexual dimorphism. Okay, now think about this. Sexual dimorphism is when the males have a mane, for example, to indicate to the females that they are male, or they have very long canines. Think of baboons and chimps and gorillas. The males tend to have very long canines to indicate that they are male. Well, if you're bipedal and you're upright, I think we can see that you're male. Okay, so we don't need to have teeth, for example, to indicate to other members of your clan, of your tribe, of your group that you are male. We can indicate maleness or gender in other ways. The jaws of modern humans are in a gentle curve rather than in a U shape, and this facilitates speech. We'll have a look at some pictures just now to clarify what we mean by that. There is a large, highly developed brain, particularly this frontal lobe, okay, your forehead, which allows, as we've spoken before, for the development of intelligence, and in particular, cultural intelligence. We have increased dexterity. We're able to use our fingers and our hands in an enhanced way for tool usage. We have evolved a highly sophisticated set of languages, not just one language, but a highly sophisticated set of languages that extends from the spoken language to the written language to the use of symbols to communicate with each other. And so, if you have a look at human skulls compared to chimpanzee skulls, compared to monkey skulls, we can see an increase in size. You can also see the shape that has changed greatly. Here we can see the bottom view of a human skull compared to a dog skull, for example, and we can see that the foramen magnum, that is where the vertebral column attaches itself into the brain through the skull, has moved forward, which is a very clear indication of bipedalism. You also need to be able to look at pictures of the hips and the leg bones in order to convince an examiner that you know about bipedalism and the shape of bones and the hips in connection with bipedalism. I've enjoyed my time with you this afternoon. I look forward to seeing you again next week. Goodbye.